Okay, hey guys, welcome to Android Study Jams, which is hosted by PES DSC. So, in this session, we will be covering the first track, that is Introduction to Programming from Android Study Jams. So, this is a collab between DSC, PES and PES. So, my name is Irfan, and I'm the Android facilitator for PES campus. So I've been building apps for 4+ years, and I've been a part of the Android development community here in PES EC for a while. And I'll be covering the first half of this entire course. So I'll be introducing you all to Kotlin and a couple of basics of Android. Now, in order to go about this course, these are a couple of prerequisites that are needed. So the first is that you need Android Studio installed and set up. You need an active internet connection, and an Android device and a USB cable or an emulator for running all the apps that we'll be building. So for this first half, we will be the learning objectives for us are these 4 points. So we will be learning how to build basic Android apps, how to set up Android Studio, and also introduce you to the Kotlin programming language, which is actively used for building Android app these days. So as you would have noticed in the links that we've sent, there is Android Basics in Kotlin course that Google has provided to us. And this course is accessible to all developers to use. And these courses allow you to gain badges as well to reflect your skills. So what we will be doing is covering these concepts, and these units are free to you for exploring. So the first unit that we'll be covering today in this session is Kotlin Basics for Android. Now, if you have opened up the site and have been browsing through, you'll find that there are pathways that you can use to access and learn skills. So this is an example of a pathway. You can see that there are 4 pathways under each unit, and you can go on completing them at your own pace. So all of these pathways have quizzes at the end, and these are all for you to complete yourself after this course ends. So now I'll be giving you a brief concept overview. So what is Kotlin and why Kotlin? So Kotlin was an initiative between Google and IntelliJ to build a programming language that is ideally suited for Android development. So Kotlin in general helps developers be more productive. It makes developing Android apps more easier. So for the introductory session now, we will be using the Kotlin Playground. And on this, you can write and run Kotlin code in the browser. So this link will be shared shortly. So Kotlin, why Kotlin? As you already know, Java already exists for building Android apps. So why is there a need to learn Kotlin? The first thing is that it removes boilerplate code. So what do I mean by boilerplate code? Boilerplate code is any code that is duplicated in order to maintain consistency. So for example, let's say you have to initialize, maybe an example would be your main class in Java, your void main. That itself is boilerplate. Now, that is a very small example of boilerplate code. That's the necessary component. It's always needed and it's necessary. But imagine if those components kept reusing. Every time you had to use a certain function, you needed to redefine that entire segment. That is what a boilerplate code is. So Kotlin removes that for us in Android. Apart from that, you would have noticed in Java, there's a lot of thing is equal to new thing. Anytime you want to declare a variable, create an instance of anything, you need to do this. And there are many more variations of this. In Kotlin, it's not that way. Apart from that, it's easier to use and learn. It's very similar to Python in terms of accessibility and ease of use. So now let us get into the Kotlin Playground. So in order to get into that, just search up for Kotlin Lang, and you will find the Kotlin Lang Playground. So this is your online Kotlin editor. So here, let us start off. I'll be introducing you guys to the basics of Kotlin. So over here, you can see that. Let me just clear this old code off. All right. So over here, as you would have expected, even Java and C, you would have a function main. Now, in order to, I'm going to be talking from a Java-based perspective. So I'll point out a couple of main differences between Java and Kotlin. First is that in Java, let's say if you wanted to declare an integer variable, so that will be something of the form int a is equal to 5. But in Kotlin, it's not done this way. In Kotlin, what we do is we declare a var a is equal to 5. Now this is dynamically sized. So that means that it's similar to how you do it in Python. You don't need to worry about which data type it is. Now, let's say we want to print it out. So we have println, which is similar to Java's explanation. And now if you want to run any piece of code, just hit run. And there you have it. So this is an example of a data type. So this can be a string, a queue, a list, anything of that sort. Whatever you want it to be, it can. Now, a couple of times you will also need variables that are fixed. Let's say you do not want a to be remodified to, let's say, 7. Anything, you want it to be a fixed constant, for example. In that case, in order to make a variable a constant, you make it a val. A val prevents any changes. So giving you an example of this, if I make this var, and let's say I make this 6, and I'm going to print this again. So this shows up. But the moment I make it a val, it cannot be reassigned. It will stop the compilation or the execution there and compilation there and show that it can't be reassigned. So these are your basic introduction to your variables in Kotlin. Now, in order to declare functions, now that's the next step that we need to do. You would have noticed that we have this fun keyword over here. That is your declaration of a function. In order to declare a function, the keyword that you use is fun itself. So let's declare another function here. Let's pull this up. So fun add. Let's have it have x and y. What it will do is it will return x plus y. Now in here, it is have val a as 5 and var b is equal to add a comma 5. Let's print b. Yeah. So in here, whenever you're passing a variable inside your function, so let's say this was a Java function, you'd have it declared as public void add, and then you would have your data types inside saying it's int x, int y, of that sort. In Kotlin, you will need to make sure that your value that you're assigning inside a function, for example, in this function, you're taking an x and y. You need to declare a variable type to it. So, for example, in this case, it will be int here, int here. So this notifies the function that it's going to be accepting ints. So now let us try running this code. Okay, now here. Now it gives us a new error saying that the inferred type is int, but unit was expected. By default, any return type in Kotlin is a unit. So in Java, in C, a default return type would be void. But in Kotlin, it's a unit. So in order to define the type of output that we are returning, we need to assign the return type as well. In order to do that, we do not add an int keyword here. We don't add it in here. We add it at the end this way. So function add has a return type of int. It takes in 2 values, each having the type int. And then it returns this x plus y. Now, if you run this code, there we have our output. 5 plus 5 is 10. So that is your basic function declaration. Going over it again, we have our add function here. It is returning an integer data type, first variable, second variable, and their data types. This is how you go about declaring a function. Now, coming to the next part of it, and this would be the last part that I'll be covering before we jump into Android Studio. So that is your basic for loops. So in Kotlin, it's similar to how you'd go about things with in Python. So in Python, you again have for I in range 0 to n, and it'll iterate it n times. Or maybe you have a list of items. So you just say for I in items. Similarly, in Kotlin, you have for I in, instead of the range keyword, for example, let's say I want to print out elements from 0 to 10. I need to type it in this way, 0 to 10. Double L. And then I just print it out. So this is your basic for loop in here. Now, if this was a list, so let's make it a list over here. Let's have a val of items. Let's have the A, or let's have it be 1, 2, 3, 4. And then we run, let's just duplicate this. We have our list here. So here again, you need to define the, you need to give it proper braces over here. So, or rather, let's skip this out for now. Just keep over a basic range over here. All right, so that is your basic for loop iteration in here. Now, the next, this was your basic introduction to your Kotlin programming language. There are a lot more exercises that you can do, and in the Google code, in the Google Study Jams link that we've shared, you can access the entire unit wherein which you can practice your Kotlin skills. Apart from that, you can try out their entire series of courses available on Kotlin's site, where you can try out examples and learn Kotlin at the same time. So let's head back to our slides. So the next thing that we're going to be doing is Android Studio. So Android Studio is your official tool to build Android apps. So originally you would have heard of Eclipse. That was used back in the day, but now everything has moved over to Android Studio, and this is where all the development for your Android devices happen. So whether it be Flutter or native Android development, this is what you use. Apart from that, if you do not have access to an Android device, and if your computer has the capacity to run an emulator, that is the best approach you can go for. An Android emulator can be downloaded through Android Studio and allows you to run your app on your computer. So if the advantages that you get are, it's faster if you have the resources, or if your computer is fast enough. Otherwise, I'd recommend that you use your own Android devices to run your applications. So let's head down to the basic components of your Android applications. Any Android app has this core function, the core component of it, and that is your user interface. The user interface covers every single object that is interactable by a user. So whether it be a list, an image, a gallery, whatever it be, that entire screen that is available for a user to interact with is your user interface. So for example, in this app shown here in the red, you can see that the app's user interface covers this top bar up till this white bottom line here. These are system interfaces, and these are not frequently used in applications. This is for an app developer, this is the entire screen that you have access to interact with, to make a user interact with. Now, for the next couple of slides, let me start up an Android application, and I'll take it through there. So let us head into Android Studio. So let us start a new project here. So in order to start a new project, select, okay, let me go back here, start a new Android Studio project. In here, you will have this following screen. So you can see that you can develop for phone and tablet, Wear, TV, automotive, Android things, whatever it be the case. So for our purposes, we are going to be using, we're going to try to build a basic greeting app, which greets a user as they log in. So over here, you can see that there are various activities available: bottom navigation, maps, full screen activities, navigation drawers. You have native C++ for any game development, all that kind of stuff. What we are going to be doing is we want an empty activity. So we're going to select that. In here, let's give it an application name. Let's give it Android Jams. Okay, and let's give this as a package name. Can be anything. That's completely up to you. Note that once you put a name, it's better if you don't change it. So that's something you need to keep in mind, especially when you're building production apps. So in here, you can see that you have two options, Kotlin and Java. Now you can build an app in Java and have certain classes run in Kotlin. That's allowed since Kotlin and Java share the JVM. Both are Kotlin is built off Java. So you can pick either, but in this course, we're going to be doing Kotlin. And then over here, you will have a list of SDKs that you can build with. Now, when you install your Android Studio, you'll primarily get one SDK. That will be probably around API 26 to 29, somewhere in the middle. You'll have one SDK available to you. All these other SDKs allow you to develop for applications on that particular device. For example, if you choose, let's say API 16 right here, Android 4.1 Jelly Bean, this allows you to build applications that will run on any phone running Android Jelly Bean upwards. So anything from Android 4.1 upwards up till 10 will run your app. But it's not the other way around. So if you build something for Android 9, it could run for Jelly Bean, KitKat, or Lollipop, but it's not guaranteed. So because there are a lot of changes that happen on in these versions. So ideally, pick something that you are sure of, you are comfortable with. For example, at the bottom here, you can see that how many devices it will approximately run on. For in order to use the new features that have been released ever since Lollipop came into existence, you would go with something like Android 5.0. This allows you to run almost every feature that is available on even the most modern Android 10 devices. So that is why we prefer to go with Lollipop. Apart from that, you can even choose Oreo, and it has even more compatibility. But for our case, let's go with Lollipop. So we're going to select that here. You'll see a bottom checkbox here. We are not going to be checking that. So this is essentially allows you to have backward compatibility. So it allows devices running API 14, for instance. It'll allow them to run your application. Not perfectly, but it'll be able to run. As I said, it'll have some issues running. By default, Android comes with its own support library, and we won't be using these legacy ones. So you just got to set this up, select your SDK here. For your purposes, let's just go with whatever SDK you have available. So I'm assuming I'm going with API 28 Pi over here. So finish. Okay, so now this is our basic Android Studio screen. Over here, you'll see that there are a couple of processes running. We just have to wait a bit till it completes, after which we can start it off. So meanwhile, while this happens, let me just give you a brief overview of the entire structure here. So on the screen, you can find this particular section here on the left. This is your projects view. This is where you handle everything related to your project. When you select project, you have access to all the files that are available for your application. So your images, any images that you've had, all your source code files, all your build files, anything of that sort, all of it is stored here. Apart from that, you have a resource manager here. This allows you to access all the additional resources that you have used in your application. For example, it could be an image, it could be a font, anything of that sort is handled in there. Now coming down here, you'll find a couple more: structure, favorites, build variants. These two features, structure and build variants, not so structure. All these three features are used when you have a large scale project. So when you want quick access to certain features, when you want to know when you want to go to a point in your hierarchy, that kind of stuff. So that is your left tab. Up top, you'll find your entire basic options menu here. Now for our application, we will be syncing this to GitHub so that we can put it up for you guys and you will have access to it. So in order to do that, let us just switch over to recording account and let us set up version control. So create Git repository for Android Jams. Okay. Yeah, so now that's been created. what we need to do is share this project on GitHub, creating a repository name, remote description, share. All right. Okay, so the initial commit will contain all the files that have been auto-generated. So you just click add, and in a couple of minutes it will be available on GitHub. So while that happens, let us get back into our main development. So here you can see that you have this is your basic structure. Once your Gradle is completed, you can see that this is your basic structure. You have your application here, manifests, Java, and res. So let's break down each of these features first. So your manifest file is a template of sort. Consider it to be the index of your application. It talks about the name of your application. So the icon you're using, the name of your application, the theme of your application, all the different views, the user interfaces that you have. So this particular component, we'll dig into this in a little bit. For now, let's keep this out. So as you can see, consider this to be your index for your Android application. So now you'll find another folder by the name of Java. Under Java, you'll find three folders with the same name over here. These are different classes. So the first one is where you build your application. The second one is your Android test. These are testing files. So let's say you want to test your Android application on a certain pattern or a certain use case. Now you could do it manually by just doing that same experiment over and over again on every time you update your app, but that's too much work. In order to avoid that, developers generally go ahead and create tests which allow them to automate such repetitive tasks. Then coming down here, you'll find another folder that just says test. That the previous one was Android test. This one is a unit test. So the previous one, your Android test, is an instrumented test. What do I mean by that? Is that it tests the app as an entire structure. So let's say you built a calculator app. It'll test the entire app right from where the user interacts with it, the operations being performed, everything. Now, a unit test is one particular component. So let's say you're building a calculator app and you want to see if your addition is correct. So what the demo already has here is that this particular component. So addition is correct. It's just going to assert that the action you're performing, given the function that you're using, is correct or not. So these allow you to test on a granular level. Now, after your Java folder comes your res folder. So down here, you can see these are the 4 basic attributes that are available initially to you. If you want to add more images or anything of that sort, they come in as different folders altogether. In order to create a new folder, you just right-click on it, new directory. And that's how you create your different folders for different items. Now, they follow a predefined standard. So you will have to look up for whatever type of media you're trying to save. A font would require a different folder. An image would require a different folder. A video may require a different folder. That's something you need to look up, and there's a predefined folder name for it. So the first thing is your drawable folder. The drawable folder is where you store all your application images. So it could be a basic application logo. It could be maybe a user image. It could be anything of that sort that is by default shown on all applications. So let's say you're building something like Facebook, for example. So in this case, you won't have your user profile images saved here. You'll have it directly loaded locally. Any image that needs to be showed all the time, so it's going to be shown on the app at all times. So that kind of image goes in here. The next folder is your layout folder. This is where you define how your application looks. So let us open this up. So over here, you can see that it has nothing basically, right? It just has a hello world text box in the middle, nothing else. This is again what we'll be building in a little bit, so just stay a bit. Next thing that comes is your mipmap. Mipmaps are icons, images that have multiple qualities. So for example, let's say you're building an Android application and there could be someone using a HDPI screen or someone using an MDPI screen. By that, what I mean is a lower resolution device, a higher resolution device. So Accordingly, if you have your images stored, this allows you to display images at a better quality. So those are the reasons that all of these different formats are there. You can see just different iterations of the same image again and again. Now, whenever you create an icon or whenever you load an application icon in, right, the mipmap function automatically takes care of creating all these different versions of it. So that's something you don't need to worry about. The final one is your values. Values is where you define attributes for your application. For example, over here, we've defined these basic colors for our application. These colors can be accessed in our layout and they can be used to color items or draw them, whatever be the case. Apart from that, you'll find another one that says strings. Now, you would have noticed that most applications have the ability to uh, translate. So, by changing a language, the application completely changes its text as well. So, in order to do that, you need to define every string, every text that you display in here. So, a quick example will be shown in a bit. So that will help make you understand the importance of strings. Essentially, if you want translations, if you want your app to be accessible by all, this is where you need to store your text. Final one is styles. Styles define particular themes, for example. So let's say you have a box that you've designed and you want it to look the same way every single time it's shown. So one approach would be to just copy it again and again into the source code in your layout. But instead of that, if you just make it a style by defining the color, the size, the attributes of it, you can just import the style in here and have it used. That is your basic style function. So let us now just run this basic Android app here. So in order to run your app, the first thing you need to do is have one emulator. So in order to if you have a device already, just connect your mobile device to your computer and it will show up here. You need to enable developer options on your mobile phone in order to have this. So make sure you do that before or you won't be able to detect your phone here. So I'm gonna be going ahead with an AVD. So in order to create an AVD, you just select Open AVD, create virtual device, and then here you can select your phone size, resolution. Click next, you select the API that you want to use, Noga, Q, Pi, Oreo, whatever it be. These downloads take a little bit of while, so that's something you need to keep in mind. Now, once you click next, it'll give you a couple more features and it'll build a new device for you. As of now, I already have a couple of devices and I'll be going with that. So let's start up our Pixel 3 here. Okay, so our emulator is booted up. Now in a bit, we should have the app launched too. So at the bottom over here, you could see that project configuration, all that app is running. We launched our AVD. In order to run our application, we click the run app, and that would start our application in here. So you can see at the bottom it's executing tasks. Okay, give me a minute. Apparently I'm having some mic issues. Sound. Hello, hello, hello. Entire screen. Okay, so here you can see that we have our application built here. Let me open up that, yeah. So over here you have your basic Hello World application. So the moment you run the first application that you build, this is what shows up. So the basic hello world text, no functionality, no features, just a basic thing. So now let's go about modifying it. Now the objective that I want is whenever maybe I open this and press a button, right, it should show up my name, for example. So how do we go about doing that? In order to do that, we have a couple of components we need to take care of. So in order to see what are the different options that are available to us, just click on palette. And over here, you can see that these are the features that are available. So in here, you can see a text view, button, image, recycler, scroll, and it keeps going on and on. Multiple views available. So for this purpose, I'll be teaching you these three views: a text view, a button view, and image view. A text view allows you to display text. Essentially, it's this hello world here. When you select this, this is how a text view is. So let's start from scratch. Let's delete this. And let's say I want a text view in here. So now I have a text view. Now this text view needs to be aligned with the screen, right? It can't just be anywhere. So in order to do that, you have a parent layout. So this white screen you see at the back is your parent layout. Now, the best way to go about building your screens is not via this drag and drop interface. It's easy for you to drag items in and build them, but for better control over them, it's suggested that you go into your code or your split. This allows you to modify your layouts accordingly. So let me jump into code here, and you can see this is how my XML. So this is basically XML code. This is how my layout looks like. So you can see that I have a constraint layout. Basically, there are three types of layouts. There are more, but these are three basic types. So one is your constraint layout, the other is your linear layout, and the other one is your relative layout. Now, a linear layout aligns elements linearly. So it's going to be one above one below another, that kind of sort. So if you want to display a list, anything of that sort, that's when a linear layout would come in handy. A relative layout allows you to position items relative to each other. And a constraint layout allows you to set constraints that map items. The ideal and the most recommended way to build any layout is by using a constraint layout. So that's what we're going to be doing over here. Now, let me give you an example of how this would look like if this was, let me just close this. Yeah. So if I make this now you can see that on my screen, I'm right here. My text box is right there. But if I make this a linear layout, you'd see that it moves to the top. That's because it automatically gets aligned because of your linear layout. Now, let me go back here and make it a constraint layout. All right, so now my constraint layout. Now, in a constraint layout, you need to define constraints, right? So in order to do that, you will have to map this item to certain objects or boundaries. For example, right now, this is the only object on screen. So I'm going to map it to all the four edges so that it knows the constraints that it has. And then I can accordingly position it anywhere inside. So when I position it here, you can guarantee that on any device, on any screen, it's going to show up in the same position. That's the advantage of your constraint layout. So now over here, let us take a look at the text view attributes. You can see it has an ID. This ID is what defines your text view. Think of it as how you would access this from your code. You would have noticed that we have a Java code, right? We have your main activity over here, which is your main Java Kotlin code. In order to access that, you need to give it an ID. So your ID is unique for each item. So over here, let's go and give it a text view. Let's call it a name text view. Name text view. This is where your name is going to be displayed. For now, let's say no name. No name. And that is it. You have your text here. Let's say I want it to be a little bigger. So I just type in size, text size here. Let's give it 20. You will see these are all the type of sizes available. DP, SP, all of DP stands for display pixels and SP stands for screen pixels. For text, you prefer using SP as it is scalable. For images and the other images and other media, you choose DP. For example, if you use SP, let's say if you use DP here, you will get a warning saying that it's recommended that you use SP for text sizes. So if you see any yellow light like this, it means that Android Studio is suggesting you a better way to do something. Now, let me consider the case wherein which I want to translate this into Hindi as well. In this case, I cannot manually modify this, right? I need the system to do it in some way. So when I hover over this, it says it gives us a hint saying that hard-coded string, you should use string resource. This reason is because if you want to translate, Android does it for you automatically. You don't need to worry about it. But you need to save the string in your string resource file over here. So let's do that. So in order to do that, let's just select this, click the yellow thing, extract string resource. Over here, you can find that gives you a resource name and a resource value. So saves it in your file name. So over here, let's save it as no name text. And when I click this, you'll find that over here I have a new string. New string over here saying no name. When I go back to my main file, I have that replaced at string no name text. Now my code is translatable. The next thing I want is a button, right? For now, I want this text to change when I click a button. Now that's something you need to do with code. So right now we're just defining the UI. Now let us get a button in place. So one way to go about it is just type button in here, and let's say wrap content, and then you can see that I can drag my button in here. Another approach would be select your palette, drag a button in. It does the same thing. Now in here, again, we need to define constraints to it. So lock it to your text view. You want it to be below it all times. Let's align it to the left, to the right. And let's keep it here. Let's give it a name button. Or rather, name button, yeah. And then click. Now these buttons again can be styled. So there are various styles for going about it. As you can see over here, you can give it a text color. These are the attributes tab, by the way. So that is available when you go into design here. And when I select, where's it gone? Yeah. If you have the screen at the top right above your gradle over here, you can find attributes. When you select it, you will have a list of all the attributes that are available for that particular item. Each item has its own attributes. So if you go down here, you can find a style, on click, elevation, background tint, all that kind of stuff. So if you want to edit your button, maybe have it rounded, maybe have it square, maybe have it rectangular, whatever be the case, you can define it here. Complete freedom in order to do that. Okay, so let's go about with the next step. Now we have a text view and we have a button, but we want them to one more thing is that since it's constrained, you can see that both move around as a unit. So when I go down and I go up, it automatically scales. So now I want this to be that when I click this button, the text changes. How do I go about doing that? So in order to do that, what I need to do is I need to use access this in my code. Now let's head over to our main activity file. That is under your application, under Java, under your first unnamed, unbracketed folder, you can find main activity. In here, you have your basic code. This code is what determines your application. This is what determines this functionality. For now, let's ignore these two import statements. These are by default imported in all applications that you use. Let's get into your Kotlin code. So you can see that we have a class here, main activity. This is what we are naming it. It can be anything that you want. App compat activity. This is another keyword. This is the type of the class that you're using. So this is by default in any activity, you need to have that available. So what do I mean by an activity? An activity is basically a screen. This entire screen is one particular activity. When you jump over into different screens, when you perform different actions, they are all different activities. So these activities are all linked to one another and they coordinate with each other. That is how processing happens. On top of that, there's another layer called fragments and other tools that are available for developers to use. But those are a bit advanced and we'll be covering them in later sessions. So for now, an activity is a basic screen that a user can interact with, essentially a user interface. So let's go back in here. You can see that we have our activity, we are creating it. This is a default keyword. Now, this is your life cycle. This is a life cycle statement. On create, it literally means that when this activity is created, do this. So over here, you can see that it's calling a function from a superclass. And then you can see that it is setting a content view. This content view is what your layout is. So over here, if you go under res layout, you can find that it's named activity main, and that is what I'm loading in here. This is what determines what it looks like. Let's say if I had another layout activity file, right? And if I linked it to this, that would be shown instead. This is what determines your activity. So this is what determines the user interface. So coming back here, let me just close all of these additional tabs. Yeah. So in here, you can see this is my activity. And now I want that click interface to happen, right? So in order to do that, the first thing is I need to be able to store my name. So let's just create a variable and store my name. So name could be, let's save it as, yeah. So my name saved here. Now the next thing is I want to know when the button is pressed. In order to do that, I need to create a button variable. So for that, we'll have var button is equal to find view by ID. Now let me just explain this once I finish typing this out. ID dot button name button. Okay, so here you can see that there are a couple of keywords that I've used. Find view by ID does what it says. So whenever it's finding the view given an ID. So coming back here, you see that my ID is name button. So find view by ID finds an ID with this particular name in this particular view. So you need to make sure that the ID that you're assigning is present in the view. You should not assign IDs that are not present. It'll just cause your app to crash when the application is run. So you won't even be able to detect it till the application runs. So coming back here, you can see that I'm giving it a type. It's a type of button. Now, when I hover over this, you can see that it'll show it's not used, but the moment when I use it, it'll show that it's a type button. And then here I'm using the same r.id.button. This variable is automatically declared the moment you give it an ID. So that's something you don't need to worry about. Now, apart from that, we also need to edit this text view that we have, right? We wanted to change its text. So let's create a text view as well. Let's find our text view. And let's, again, same thing, find view by ID, text view, r.id.text, name text view. And there we have our button and a text view. The next thing is we need to change the text when the button is clicked. So let us first detect for button clicks. In order to do that, you have this button dot set on click listener. So there are many different variations. Set text, set background, there are a lot of setting that you can do. So let's come in here and let us set a listener. Now in here, it'll ask us to define an on-click listener. Now, in order to define an on-click listener, you will need a function. You need to override the default function that's there. Think of it as overriding any class that you already have. So let me just type this. Now you can see that I have a red squiggle line, and it says that it has a type mismatch. It's saying that it needs an on-click listener. Now you would have heard of the term, you would know of the term inheritance, wherein which class inherits features of its parent class. Similarly, we need to inherit features of this click listener. In order to do that, what we do is we press Alt Enter. And over here, you can see that it allows us to two options. One is create an extension function or implement this interface. So let us implement this. Click OK. And now we'll have a function here that says on click. This function allows you to detect to a click event. So now inside here, this v.view is used to determine which button is being clicked. Let's say we had 3 or 4 buttons, right? In that case, we'd have to use the ID that this person has. So v.id, you can see that v.id will give you an ID. And then we'll have to compare it to all of these IDs and see which one it is. For now, we don't have any. So we just have one button. So as far as we are concerned, we just have one button. And whenever it's clicked, we need to change the name. Now, whenever it's clicked, we need to change the text view's name. So we type text view, but you can see that it is not detected. It's showing a red line saying that there's no unresolved reference, but it's defined in here. Now, that is because we do not know. This is context sensitive. You can see that this entire code is covered inside these braces. It's not visible to any code outside. So, in order to make that happen, we need to move this line outside. But you cannot define any view without having the parent, right? So I can't just move this line. Let me just copy this line and paste it here and hide this. You can see that it gives me no errors. But the moment I run the application, you can see that it gives me no errors right now. But the moment I run the application, it'll immediately crash. That is because you're trying to find an element that hasn't even been created yet. Because you're defining the view here, but you're trying to access it here outside. In order to avoid that, what we do is this. Let's go back here. So we move our declaration outside. So we can make it as var text view is of a type text view, and we set it to null. But you can see that again it gives you an error saying that you cannot save a text view object as null. How do we go about solving it? We just tell the compiler, and that's one advantage of Kotlin, is that we tell the compiler that I'm not going to define the type here. It's going to be initialized later. So late init of our text view, and that solves our issue here. This keyword means that there is a variable and that's not initialized now. It's going to be initialized later, and it's going to be initialized before it's being used. So consider this to be a promise statement that you make to the compiler. So we have our late init variable defined here. We have our text view being assigned here. And now we have our button also set here. So you have a button setting. And now when it's clicked, we want it to change the text. So what we do is, let's say text view dot text is equal to name. Now again, you can see that name isn't defined. It's defined locally, not globally. So since it's a variable, we can just pull it out and put it in here. And now it's defined. So all we have to do is save this, Control S. We have check our files to make sure they're aligned and connected. All right. And the next thing we do is run our application. Oh, there we have it. You have no name, you have your button here. When we click it, my name shows up. So that is your basic application done. Now, in order to see what are the steps that are happening in your app, and let's say you want to notify when a button is clicked, right? Let's do one more thing here. We want to print it out. But as you know, you can't exactly print out any statement you want. A phone isn't exactly a computer again. So in order to do that, you have to log it. So we have a statement by the name log.debug, that is D. And let's give it a tag saying app, or rather, let's give it a tag saying my name. And then we can give it a message saying, I have been clicked. This is a very important statement that is very useful when you're building apps. Knowing what happens is something that's very important. So what I'm going to do is I'm going to run the app again. Let me open up my emulator here. You can see here when I click it, nothing happens on screen. But at the bottom here, you can find this tab, version control, terminal, build, logcat. What we are interested in is logcat. Select logcat. And then over here, we're going to type in the tag that we gave. Now you can see that the messages are popping up. So whenever I click it, you can see that it shows up. So any action that happens, you can log it this way, and that allows you to monitor your application's progress. So that is your basic Android application built. So what we went through was our text view. We went through our buttons. Image views are a similar thing. This is what is going to be done in the code lab, and that's something that's an exercise for you guys. So now I'll be handing it over to. Okay, so yeah, so now I'll be handing it over to Shubham, and he'll be continuing the next half of this session. Okay, over to you, Shubham.
Yeah, hi. Thanks, dude. One sec, let me start sharing my screen. And all right, my screen should be visible. So hi guys, my name is Shubham. I'm third year CSE from DSC PESU RR campus. I'll be I'll be explaining the unit 2 of new to programming track today. So yeah, let's directly get into it. So so Irfan already covered the basics of Android, so a little bit about Kotlin. I'll be just extending whatever he has explained. So we'll be going over classes in Kotlin, visibility modifiers for classes for members of classes, and then we will be looking at array like data structures like lists in Kotlin. And once all these basics are cleared, we're going to jump into Android. So in Android, we'll be looking at the structure of the XML files. We'll be looking at groups, view groups, which are basically layouts in XML. And we'll be looking at this concept called view binding and recycler views. And to finish it off, we'll be comparing styles versus themes and general practices while building an Android application. So let's start. Okay, classes. So like classes in Kotlin can be like, the basic definition of classes. It's a blueprint for objects. So Kotlin provides support for various kind of classes. So the two classes we'll be looking into today would be abstract classes and data classes. So abstract classes are something which are like unfinished classes. They do not have all their implementations. The members are initialized, but you can't use them. So that's one reason why you cannot create an instance of an abstract class. A data class, on the other hand, is basically a class specifically designed just to send and receive data from other interfaces. So like if I'm going to let me show you guys what I mean. So if I create this, let me create an abstract class. So to create an abstract class, you require the keyword abstract. You create a class, let's say vegetable. All right, we have a vegetable. We can give it some members. Abstract, oh no, I got the spelling wrong. Abstract color will be of type string. Let's give it another one. Abstract, I give it, let's just say size for now. Will be of type int. So as you can see over here, the abstract class vegetable has two members. Both these members, color and size, are not initialized. They're just declared. So if I try to call vegetable class, if I try to create an instance of it, I create an instance of it where so vegetable. Oh no, not sure why it's happening. Vegetable and yeah, and let's just say I want to print this object. It doesn't make sense, but let's go ahead anyway. So this should fail. So yeah, as you can see, you cannot create an instance of an abstract class. So to fix this, what you would do is you would create a subclass. Subclass like let's create cucumber. Okay, it's just I'll be inheriting the class vegetable, so I will say vegetable and that. Now, since I'm inheriting from abstract class vegetable, I can define the color and size of vegetable. So I can say, so to define color and size from vegetable, which is the superclass, I'll be using a keyword called override. So override I'll color first green. Okay, it's just a random values. Okay. So now we've defined cucumber, which is a subclass of vegetable, and it's inheriting color and size from vegetable, and then initializing their values over here by using the override keyword. So now if I go ahead with cucumber, and now I want to view color and size. For that, I'll be using this keyword over here called width. I'll explain in a bit what width does. Let me just write the code. Up until that. Uh, color. Right. So what width does is it takes all the instances. No, it takes an instance of a class. So here that would be cucumber, uh, and it goes through all the members of the instance of the class. So the members of cucumber over here is color and size. So when I access it using this code over here, it'll directly show me the values green and 5, or at least it should. So let's test it out. Okay. Let's have a look at that. Oh, I forgot to that. Yeah. So now you can see that I've created an instance of cucumber. And using the keyword width, I'm getting the color of the vegetable. I'm getting the size of the vegetable. So that's abstract classes. That's the override. What do you call keyword? That's the width keyword. All right, let's go back to slides. So data class, I'll show you an example later on. For now, let's just go ahead. And yeah, as you can see, there are other types of classes: sealed, nested, enum classes. These will be covered maybe in later on sessions, or you can check them out by yourself. So that's classes. And already kind of covered inheritance, what inheritance is, but the basic definition of inheritance is you know getting the member classes from a superclass to a subclass. So if you look at this diagram over here, legume is the subclass inheriting all the members of vegetables. And again, lentil is the subclass of legume. It'll inherit all the members of legume. So it keeps going on like that. All right, visibility modifiers. So let's go. All right, let's stick to this actually. So what visibility modifier does is, suppose you have some members in a class and you don't want them to be accessed outside that class. So you use visibility modifiers to control that access. So Kotlin provides 4 visibility access modifiers. They are public, private, internal, and protected. So yeah, the definitions are right there. By default, you would use public everywhere, and private you would be using if you don't want what do you call don't want it to be accessed outside the class. And yeah, public and private are actually the most two commonly used ones. The others are I wouldn't say it's common, but yeah, it's available. All right, so moving on. All right, array like data structures in Kotlin. So Irfan already covered like lists. So like he showed you how a list works, how you can iterate through a list. So list is basically an array like structure for Java. In Java, we call it arrays. In Kotlin, it's called lists. In Python, it's called lists. So the thing about lists is it's not mutable. So like if you want to add an element or delete an element after it's been created, you can't do that. So if I show you that, let me just ignore all this. I'll just say var list1 equals to let's say a list of string to list of b b and c. All right. So now I have a list and it has ABC in it. If I print it, oh no, wait. Right, ABC. Now, suppose I want to add an element to it. This one dot add. So yeah, as you can see, lists once created, you cannot modify them once they're created. So the workaround to this would be is what we call mutable lists. Let me just code that up. Oh wait, it's mutable list of. Same thing again. Right. So, oh wait, let me just comment this out. The list. All right. Yeah. So now I have ABC, which is a mutable list. But now the difference between list and mutable list comes over here. If I say list2 dot add the then I copy this over. Yeah, so it works. So that's the big difference between list and mutable list. You can add subtract elements, you can add arrays, you can add lists, you can append lists to mutable list, you can delete lists from a mutable list. So yeah, but what you can't do is say now it's defined as a string, right? Say if I try to add 1, let's see what happens. Yeah, so the thing about list and mutable list is that they are data type specific. So if I define string, I cannot add an integer or a Boolean value at the end. It always has to be a string. So if I want 1 to be present in the mutable list, it's gonna be a string. So that's that. Okay, so we're done with lists. All right. I've already explained you guys what with is, what override is. Late in it, Irfan kind of explained it to you guys. I'll be demonstrating an example again with late in it, and these are some of the inbuilt functions for mutable lists. There's add all. Add all is basically you take a list and you append it to the end of a mutable list. Remove is basically you take an element, you want to remove an element from a list, so you just put that element in there and it's removed. Clear is basically you reset the list to a null list. It has 0 elements. And is empty just it returns a Boolean value whether the list is empty or not empty. That's all. So that's that. Okay, now we're getting towards Android. Getting into Android. So right, XML. So the thing about XML is it's used to generate the user interface for Android apps. For those who don't know, XML stands for Extensible Markup Language, and the user interface is made up of 2 parts mainly: layouts, which are also called view groups, and views. So to differentiate between layouts and views, layouts basically contain the views, and layouts can contain several other layouts within them. So that's basically the difference. Layouts are containers, views are objects within the containers. That's that. Here's a basic structure of the XML. So again, constraint layout over here is a layout. So the thing about layouts is they always have start and end tags versus views. It's optional for them. So I can, wait, let me pull up Android Studio. The thing about views is they can or cannot have, they may or may not have, what do you call it, end tags. So that's a good thing about them. It's usually preferred not to keep end tags. Let's see over here. Should I create a new project? Yeah, I'll just stick to this. Oh, okay. Open existing project. I'll just create a new one. It's okay. Let's go. Let's call it Study Jam Session 1, Unit 2. Just wait for it to load a bit. Right. It's taking a bit longer than I expected, but that's okay. So basically, views can have end tags or they don't have end tags. That's just an option over there. Right, view binding. That's another topic I have to cover. One second. Right. I've made the text a bit bigger. I hope everyone can see. So yeah, over here you can see text views. They don't have the ending tags, whereas the constraint layout over here, which is the layout, has the ending tag. So I can actually change from this to this. Both are acceptable, right? Okay. Okay. So view binding. To explain what view binding is, we're going to need quite a few views over here. So let me just dump some in. All right. Let's just assume that you have a really huge application with a lot of views, a lot of layouts, and you're trying to reference them. Okay. What does this have in? Okay, let me just change it to. Right. Yeah, this is much more visible. So yeah, let's just assume that this is a huge application with a lot of buttons and views. For now, I've taken 3 buttons and 3 text views, and say I want to reference them. Do they have IDs? Okay, button 1, 2, 3. Text view. I'll just call this text view 1. Okay. Right. So let's go to the main activity. So now, if I want to reference each button, I will have to do var button 1, find view by ID r.id button. So if you see, for each element, for each view, I'm actually doing a find view by ID. So here I have only 6 elements. So this is fine actually. So for 6 elements is fine. But say you have a bigger application than this. Doing find view by ID for each one of them is going to spend a lot of time. It's going to take a lot of time and resources to find that button using the ID. So what you would do is you would go to your Gradle file, you'll open the app module. You would say, one sec. I think I forgot what I'm supposed to add here. Let me just Google that up. View binding, just a sec. Yeah, build features, view binding true, right? Build features, right. View binding true. Fish binding equal to true. Oh no, can't even copy it. One sec. Right. All right, so yeah, you go to your app Gradle, you enable build features view binding equal to true, and then you come back over here. You define a late init. So this is the application of late init, what I was talking about, late init binding. So since my since my class is called main activity, I'm going to call my what do you call it? The type as main activity binding. Oh wait, what did I do? Yeah, main activity binding. It should be fine. Yeah, it should be fine. And here I'll say binding equals to nope. Let me just have a look. Activity main binding. All right. Activity main binding dot inflate. Layout inflate. And finally, binding dot root. So what I'm doing, why is this still not resolved? Okay, it's activity main, not main activity. Right. So what I'm doing here is I'm creating a variable called binding, which is of type activity main binding. So say your class is called XYZ activity, then it would be called activity XYZ binding. So it just follows the naming convention of your class. The second, what you do is right now, you're filling up binding with all the, what do you call it? All the, all the IDs of present in the current XML file. So all the button 2, it's all being, mapped to binding. And finally, you're setting the content view to binding root. Binding root is basically the topmost level view. So that's what you want. Initially, it was, I think, activity main. So activity main over here is binding root. So once you've done that, you can completely get rid of this. You don't need to keep doing find view by ID anymore. And say now, what can I do with this? I can, right, I can do binding dot text view dot, I set text, no, text, text equals to, I could just say hello world, I guess. Oh, no, wait, what I can do is I can get the text present in the text view. So one text to string. So initially, if I wanted to get the text from text view one or text view, I would actually have to first create a type text view using find view by ID, and then I reference the text, then I reference the string, convert it into toString. Here instead, I can do it in just one line. So that's the advantage of view binding right there. Let's go back. So yeah, okay, view binding is done. So this is actually a screenshot from one of the apps from the pathways itself. What we'll be covering here is the edit text, radio buttons, and switches. So what each of them does is, let me start a virtual machine. Wait, I already have the code ready. I guess I should. Open typing application. Uh, so I'm using a Pixel XL Android API 29, and I should have a right. Here's my device. So the edit text, radio buttons, and switches. These are what I'll be covering for today. Edit text is basically any input you want to take using the keyboard. Say passwords, names, addresses, numbers. So as of now, I've told it to take numbers, so hence just the number keyboard comes up, and yeah, that's edit text for you. And let's go to radio buttons. Radio buttons is basically, just using one radio button doesn't make any sense. You use a bunch of radio buttons in a radio button group. So what a radio button group does is it allows selection of only one radio button at a time. So if I go here, if I click amazing, I can't click on amazing and good at the same time. It's either one. It's mutually exclusive, you could say. So if I want to change that, I can. I'll have to remove this. So I'll just take it out, I guess. Move it out. Move it out. And so as you can see, tip options was actually my radio button group. Okay, and now I've taken out all my radio buttons from the radio button group. And if I apply changes, is it done? Right. So now you can see that I can click amazing, good, all at the same time, which kind of makes no sense. In this case, you're better off actually using a checkbox or literally any other type of input type. But radio buttons are basically for mutual exclusive, inputs. It's either amazing or good or okay, not all of them at the same time. So that's radio buttons. And switches. Switches are basically binary input. You see, you can either have round up. Do you want to round up your trip or round down? That's basically the app you'll be building. I'm not going to explain it completely, but yeah, it's basically binary input, 0 or 1. That's it. So moving on. All right, recycle view. This is another amazing thing that Android provides. So suppose you have a list of 1,000 elements, okay, and you want to display the 1,000 elements on your screen. Uh, Now you could just, create a vertical layout, uh, create an adapter which prints all the 1,000 elements on the screen. You could do that, but that's really inefficient because on your screen you can at max display, like on this screen, for example, you can display 3 elements at a time. So it's kind of inefficient to load all of them at once. So instead, what Recycler View does is it takes, you know, it figures out how many views can be fit into a screen. And based on that, it keeps recycling the views. So you're not exactly loading all 1,000 at once. You're loading probably like 4 or 5 at once. And the second the object leaves the screen, the the view is reused for the incoming item. So to explain, the components of Recycler View, we have the items, which is a list of raw data. Okay, you pass the list of items to the adapter. The adapter, what it does is it converts the raw data into a parsable form for the Recycler View. Okay, so the parsable form of the Recycler View over here would be, first it'll go to a view holder. It'll get a view. It'll attach the item to the view. The view holder returns the object with the view and data in it, and then it passes it to the Recycler View. The Recycler View just gets uh, a final view object and displays it on your screen. So yeah, that's basically the life cycle of a Recycler View. Take an object, pass it to an view, display the view, and yeah. So this entire functionality is done using these 3 main functions over here. So wait, let me pull up an example which uses Recycler View. Give me a second. So let me close this. Let me close informations. All right. Currently, it's not available, but let's see. Right. So here's my Recycler View. I'm using a frame layout, which contains a Recycler View. Frame layout is just, it's another layout like linear layout or relative layout. So there's that. Inside, wait, let me just adjust it a bit. So in the Recycler View, since I'll be displaying it, from top to bottom, I've created a scroll bar which is vertical. And in order to display the items, this is what the Recycler View will actually be showing. It'll be showing a linear layout, it'll be showing a text view and an image view, all stacked vertically. So what you want to do is, let's go to, right. So I'm going to show you now the Recycler View, right? Yeah. So, one sec. Yeah, I'm supposed to show you the 3 functions. Yeah, that's right. So 3 functions: get item count. Get item count is basically the number of items in your list. So if data set is your list, you do data set size, and it gives you your list. On create view holder is basically every time you're loading an object onto your screen, you want to create a view for it. So you're going to inflate a view. You're going to add the item into that view, and you're going to return it. And on bind view holder is basically, say you scroll up and down your list. Wait, let me actually do it over here. Let me right. So this is actually your pathway thing you'll be building. So now I'm scrolling down. This is the job of the on bind view holder to update whatever's present on the current views. And on create views, what it does is it'll take the new data and load it up to a view. So that's basically it. Uh, so yeah, we're done with recycler view. And right, styles and themes. So the basic difference between styles and theme is style is applied only to a certain view or a view group. It does not apply to the entire app. Theme, on the other hand, like over here, we can see a dark theme and a light theme. It changes the style for each and every element present in the app. So you can see over here, continue is written in a light text, but in light mode, it's written in dark text. So that's the basic difference between themes and styles. Themes affect the entire app, styles affect uh, just a specific view. Yeah. And finally, general practices for Android development. So uh, these are things you just should follow. Like, it's not necessary, but it just makes your app look better, or debugging your app made simpler. So one of the first things would be create private members, utilize null safety. In case you guys don't know what null safety is, let me just show it to you guys. Mm, so null safety would be, say I create name, okay, name string, right? Right now, as you can see, string does not have any values. So if I try to print name, must be initialized. Fine, I can just say, let's say, I can say null maybe. Does it allow me to say that? Okay. Basically, any data type will not allow null to be, null to be a acceptable value. So what Kotlin has done is, it's really interesting. It allows null values to be present. So now let's say if I put my name as Shubham, all right, I'll print Shubham. Yeah, right there it is. But instead, now if I say name equals to null, so it was initially Shubham, but now I've made it null. So it should technically still crash, but it doesn't. So null safety is basically telling the compiler it's acceptable to have null values. Uh, the reason for implementing this is, a lot of times, say your app encounters a null value, it's directly going to crash. But instead, with null safety, at least your app will tell you that it's receiving null values. So it saves it reduces the number of crashes. So the same example without null safety, it's yeah, you can see it crashes. It won't allow null values. So that's null safety. And yeah, say you have a lot of strings in your, yeah, let me open up strings. So let's say you have a bunch of items to display on your on your front view, front end, okay, and instead of typing down each and every one of them within the group, within the view group or the view itself, what you should be doing is opening the strings.xml resource and adding all adding all the strings over here. So this is just a cleaner way of writing code. The same for images. You see, instead of say you want to put an image over here, as I have over here. So instead of putting it inside the view, you store it inside the drawable resource layout, drawable folder, and then you just keep referencing it using the ID or r dot drawable dot image 1 or 10 or 2. So you just go on like that. It's just more cleaner code. That's all. Uh, yeah, padding and margin. So a difference. So padding is basically, the distance between two views itself. Margin is the the distance with inside the view. I hope I'm getting that correct. But yeah, using sufficient margin and padding will basically make your app look cleaner. That's all. So I could have actually put some padding over here between the text and the image. That would have looked much better. And yeah, that's about it actually. So do you guys have any questions? Guys have any questions? We'll answer. Otherwise, we'll be ending the stream soon. Okay, I don't see any new questions popping up, so I'm assuming you guys don't have any questions. So thank you, and yeah, we'll see you guys next week, I guess. Yeah. Okay. Next week, the next class would be on 14th. I'm guessing it would be the same time. And yeah.
Yeah, so this was the first track, that is your introduction to programming from the Android Code Labs. So you guys can go ahead and try it out on the link that has been provided, and you can earn yourself badges there as well. That completes the first unit. The next unit, which covers the a little advanced concepts of Androids, will be taught over a series of 2 sessions. The first one is scheduled for next week, and the next one will be in the week after. That'll again be on Thursdays around the same time. So, all right. So
Yeah.
that is this, and we wrap up here.
Also, the code I've written, I'll add it to Irfan's GitHub. So if anyone's interested to go through that, yeah, it'll be available. All right. Thank you guys. See you.